All right, so I'm going to try again with this recording. I checked my audio was on. I hope it's not picking up the wind or the lawnmower too much. We'll see how it goes. So first, I want to do something first, and I'm redoing this maybe a little bit better the second time. Is first I want to look at the understanding, and this is just to make sure you really understand what you're doing, and then we're going to look at your problems for the doing part. Let's first go back very simply to what does it mean for the absolute value of some number. X variables could be just some number. And I think it's really important for you to hold in your mind that it doesn't really matter what letter I put in here. The letter is simply just standing for some number that we don't know. And in this case, if I say the absolute value of x equals 5, well, that's pretty easy to think about. X can be 5, right? Or x can be negative 5. And this really shows us what absolute value is doing. Absolute value is a distance. So the distance from 0 to 5 is the same as the distance from 0 to negative 5. And so absolute value is just our way of communicating this distance, and that negative doesn't really matter because you can't go negative distance. All right? And so that's when we had, remember when we have this equal sign, it's an equation. So we have, one value, in this case, two values that make this statement true. When x equals 5, the absolute value of 5 equals 5. And when x equals negative 5, the absolute value of negative 5 equals 5. All right, so that's when we have an equation. But what about when we have these inequalities? We could put the equal sign here, but let's just stick with greater than or less than. In this situation, x is greater than 5. The absolute value of x is greater than 5. And we can kind of think of this, again, on a number line. Here's 5, and here's negative 5. And I want x to be greater than that. So I want x to be more than 5, which more than 5 is over here. And it could also be more than negative 5, because if I put negative 6 in there, the absolute value of negative 6 is 6, and 6 is greater than 5. So it works out okay. And we see that this creates this OR situation. X is greater than 5, or x is less than negative 5, right? We want it to be over here. So this brings us to the OR. And I say to myself, when the absolute value, or when the inequality sign is eating the absolute value, I know I'm going to have an OR. So this is eating the absolute value. So when the absolute value gets eaten, I have an OR situation. All right, well, what if the absolute value of x is less than 5? Well, then I want, again, here's my number line. Here's negative 5, and here's 5. I want all these numbers in here. And when we have inside something, that's an and situation. It's the sandwich, right? So when the absolute value is eating the number, I end up with this kind of sandwich situation. And I just want to sandwich x in between those two values, right? The x is bigger, the absolute value is, the inequality is eating x, and the inequality is eating 5, showing that x is in the middle. All right? So, and we have a couple other situations, like when the absolute value is, let's say, less than negative 5, well, that's impossible, because no matter what I put in here, I'm not going to get a negative number. So in this situation, we could have no solutions. And if I just flip this around, if I said the absolute value of x is greater than negative 5, well, it's always, right, greater than negative 5, because it's never negative. So in this case, it would be all solutions. All right, so that's understanding. Let's start doing some of these problems, but also add, I think, a little picture in here, because this helps me quite a bit. So this is 57. And 57, when we solved it, sorry, I do not want that. 57, when we solved 57, and it was erased from what I did the first time, so we have the absolute value of 3x minus 4 plus 5 less than or equal to 27. And we said, okay, the steps are first to isolate the absolute value. So I see addition, I need to do subtraction. So I have 22, and now I need to check. I need to decide which is it. Okay, the absolute value is eating the number, right? So this is this case, so this is going to be an and, this is an and situation. And now I'm going to write those two equations. This one I keep the sign exactly the same. This one I'm going to flip over the sign and put a negative because I want to find that other side, right? I want to find the other side of the equation. So plus 4, 3x is less than or equal to 26. X is 8 point, I just remember this because I've done it, 667, right? 26 thirds. And here I'm going to add 4. Here's where I have to be really careful because that's a negative 22 plus 4. So I have to go negative 18. So x is greater than or equal to negative 6. And the reason I have this graph up here is because when I graph, this red one is the absolute value part, right? Here's the absolute value. And here's just the line y equals 27. And if we look, the two places that they intersect are here. And we know this is an and situation, so our final answer is going to be written as negative 6, right? The x is greater. See how it's eating x here and it's still eating x here? And less than or equal to 8,667. So all the values basically in between here will make this a true statement. All right, so that's why we have two answers when the graph is showing you why you have the two solutions here. All right, so now let's get rid of this and let's start bringing in some of the work that you did. So let's get this one. The order we're working on doesn't really matter. So, we want to get rid of the rest of this though. Okay. So you did this here. You said add 2 to both sides, right? You were isolating the absolute value, and you had the absolute, doesn't like my hand today. The absolute value of x minus 3 over 2 is less than or equal to 4. You had that. All right, so now we need to decide, is it an and statement or an or statement? Okay, the absolute value is eating 4, it's and. So let's go ahead and make the two equations. We have the one exactly as it is. I'm just writing it without the absolute values. And I have to flip the sign over and make it be negative 4. All right, so now I'm going to multiply both sides by 2, right? Because I see division here. You're dividing, but you see division. So when you see division, you have to do multiplication. So now I have x minus 3 less than or equal to 8. I do the multiplication over here, greater than negative 8 because that was a negative. I multiplied everything by 2. And now I'm going to go ahead and add the 3, right? I see subtraction, I do addition. So x is less than or equal to 11. And here, x is greater than or equal to, well, negative 8 plus 3 is a negative 5. So now we can have it, right? It's sandwiched in between. Here's the 5, here's the 11, and x can be anything in between there to make that true. And we could even check. Let's say we chose 3. 3 minus 3 is 0. 0 divided by 2 is 0. 0 is less than 4. Works out. All right, so next we have, let's do this one. So let's go through our steps again. We need to isolate it, and right away what I see is you see subtraction here and you did subtraction. When you see subtraction, you want to do addition. So I'm going to have 1/9 times the absolute value of 5x minus 3 greater than or equal to 5. Now, when I see multiplication by 1/9, I want this to be 1 on this side. And so I can think, oh, if I multiply this by the reciprocal, that's going to get me rid of the 9 because 9 divided by 9 is 1. So I'm just left with 5x minus 3. Absolute value, we gotta multiply both sides by 9. Can't treat it differently. All right, so now we have 45. Let's check. Is this an and statement? Which is it eating? The absolute value is being eaten. That means it's an or statement. That makes it an or one, right? So we have 5x minus 3 greater than or equal to 45, or 5x minus 3 less than or equal to 45. So add 3. 5x greater than or equal to 48. X is going to be greater than or equal to 48/5. You can use your calculator to get a decimal. Add 3. 5x is less than or equal to 48. Divide by 5. Wait, add 3, 48. I forgot to put the negative here. I'm like, how did I get the same answer? Right, when I flipped the sign over, I needed to make this be a minus 45. And this will make it be correct. So 5x is less than or equal to negative 42. So x is less than or equal to negative 42/5. Right, and this is an or statement, so negative 42/5 is like a little bit, negative 8 and then some, little bit, right? Because 5 times 8 is 40, so that's a little bit less than negative 8. And this is a little bit more than 9, and my solutions are going out from it. All right, one more. Hang with me. All right, here we go. Let's get rid of this one. Bring in the last one. We did this one. This one. This one is very interesting because it's already isolated, right? And so we have this 3, so I need to color. We have 3z plus 15 greater than or equal to 0. And how in the world do I make it 3z plus 15 is less than or equal to negative 0? That doesn't make any sense because we don't have negative 0. So what this is saying is we just have one solution. And we're going to have, we got to do the opposite. We see addition, so we need to do subtraction. And then we have greater than or equal to negative 15. We have, I don't want to x, I'm using z's here. So z, I got to divide both sides by 3, negative 5. So in this case, we got z here at negative 5 going this way, right? It's greater than. All right, so I hope this one records and you find it